In this video, we get to start chapter 6, which we're going to talk just a little bit. We're going to touch briefly multivariable functions. So here's an example. We have f of, notice how my function notation has changed slightly here. I have f of xy with a comma in the middle is equal to the natural log of x plus y cubed. So why do I have this notation? What does this tell me? This tells me that my function depends on both x and y. Now, it's not like we haven't seen functions that deal with both x and y, so what makes this different? The key difference here with what we're going to be talking about in chapter 6 is y is not a function of x. Y does not depend on x at all. So x and y are independent of each other. And that's what makes this a multivariable function. If y depends on x, then theoretically you can get everything in terms of x instead of having it both in terms of x and y. A good example of that is the differential equations we did in our previous video. That function was in terms of x and y, but y depended on x, and so we eventually got y in terms of x. But that's not the case here. So that's why when we use this function notation, we notate both the x and the y value. So, for example, if this is my function, and I asked you to evaluate this, what does that mean? Well, that just means that I'm going to plug in e to the third for my x value. It means e to the third represents my x value, and 9 represents my y value. So if I keep that same function, I would plug in e to the third for x and 9 for y. And then I could just finish evaluating that. I would get 3 plus 729 equals 732. You're going to see some where you're not just limited to 2 independent variables. You might see something like this, where you've got a function that's in terms of 3 variables. But once again, the fact that I'm assuming that this is a multivariable function, that means x, y, and z are all independent of each other. None of them depend, z doesn't depend on y doesn't depend on x. They're all independent of each other. And that's why we write it in this way. Well, how does domain work with multivariable functions? Consider this function. So x and y are independent of each other. We've got this multivariable function. What's my domain? Well, of course, with lots of functions, usually your domain is all real numbers, right? You're not bounded by anything. You can plug in any number you want. The difference with multivariable functions, like if I come up here and look at this example, if I've got 3 different variables, I can just decide, oh, well, what numbers can I plug in for x? What numbers can I plug in for y? What numbers can I plug in for z? And for like this equation, since it's a polynomial, your domain for x is all real numbers. Your domain for y is all real numbers. Your domain for z is all real numbers. But for something like this, I do need to be slightly careful. If I have a square root, my domain's not all real numbers. I am limited, right? What's my limitation for the square root? Everything inside the square root has to be positive, at least greater than or equal to 0. It's okay if it equals 0, but it's got to be greater than or equal to 0. So notice what happens if I set that up. I can't actually solve for one of my variables here. I can't say, because this depends on 2 variables, I can't isolate x and say, oh, x has to be greater than 3, or y has to be less than 7. There's no way for me to do that since this depends on 2 different variables, but what I can do is solve for one of the variables. So I'm going to actually solve for y. I'm going to add y on both sides, and I get y is less than or equal to 7 minus x squared. This actually represents my domain. It's just telling you that in order for this function to have a real output value, to stay defined, you have to make sure and choose xy pairs such that y is less than 7 minus x squared. You have to pick your pairs. So like if I wanted to test a few out, let's try the pair 0, 0. Is that in my domain? Well, if I plug this into my function, if I plug this into my domain, not my function, into my domain, if I plug it into my domain, I get 0 is less than or equal to 7 minus 0 squared. Is that true? Absolutely, that's true. So 0, 0 would be part of my domain. If I pick a different one, let's pick 9 and 5. 9, 5. If I try this point, 9 is less than or equal to 7 minus 5 squared. Well, what do I get? I get 9 is less than or equal to negative 18, which is not true, which is obviously not true. So 9, 5 would not be a part of my domain. Now, your domains they don't necessarily make it so your y value depends on your x, and right, you don't always get a relationship between your y and x values for your domain. If I go back up to my very first example, this f of xy equals natural log of x plus y cubed, what am I allowed to plug in for y? I can plug in any number I want for y. So my domain for y is all real numbers, but my x, you can only plug in positive values for x. So my domain for this first example would just be x has to be positive, and the domain for y is all real numbers. Okay, now both of the examples that I've talked about up to this point, they're all from your homework, but I specifically wanted to talk about number 7 from your homework. Okay, number 7 is interesting because they don't actually give you a function, and you might be wondering how this relates to multivariable functions. Well, the reason why is because they give you a two-way table. They give you a two-way table where the left column is your interest rate. APR. Your left-hand column is your interest rate, so it's got different rates on here. And your right-hand column is the number of years that you're setting your loan for. Okay, I'm not going to, of course, recreate the whole entire table, but I'm picking out these points because that's what my problem actually asks about. So all this problem's helping you to do is getting you used to dealing with two different variables that you're working with, right? And so in this case, my x and y, I have two independent variables. One is the APR rate, right, my interest rate, and the other one is years. And that's why this becomes a multivariable function, is because you have two different variables that are independent. And your function really is the table. The table is telling you how these two things, if you have a combination of an x and a y, what your output actually is. Okay? So let me just walk through one of these. Let's say I want to borrow $14,000. What this table is telling me is what monthly payment can I get per $1,000. That's important here, is that these values in the table are per thousand. So what's my monthly payment if I'm gonna do a 6-year loan at 6% interest? Well, these are the values that I'm going to look at for finding to use my table. In order to use my table, I need my time period and my interest rate. So 6 years at 6%, and if I look at my table on mine, I have $16.57. Is that my monthly payment? No, remember, that's my monthly payment per $1,000 that I borrow. How much am I borrowing? I'm borrowing $14,000, so I'm going to do $16.57 times 14, and I get $231.98, right? Because I'm borrowing $14,000, so I multiply that value by 14. So if that's how much I'm paying per month, total, how much am I going to end up paying? This is a monthly payment. So how much total do I pay in 1 year? I'm going to multiply that by 12. That's going to give me the total amount that I pay in 1 year. And how long am I paying this loan? I'm paying it for 6 years. Okay, so this is 12 months in a year, and this is my 6-year loan. And this is money per month. If I multiply all that together, I get $16,702.56. So we've kind of seen something like this before when we talked about amortization and things like that. You'll notice that you're paying about $2,700 more than what your actual loan was for, and that's because you're paying interest. So this represents your total amount paid. Hey, that's all the big ideas here for 6.1. In the next video, we get into how do you take derivatives of multivariable functions, and we'll go from there. Okay, best of luck with the homework. Let me know if you have any questions.